Hello, and this time we're looking at fractional indices, so something to the power of a fraction. Now there's two things going on with a fraction, and we'll talk about these examples in a moment, but just to start off with, when you have a power of a fraction like 4 to the power of 1/2, the denominator of that fractional index is actually a root. So this is equivalent to the square root, and we don't put the 2 in there for square root, but we would for other roots, the square root of 4. So this would actually give us two answers, because although this symbol, the square root of 4, is only challenging you to write down the positive root here, this here is not saying that. That's not limited to just the positive answer. So this thing is giving you, is wanting 2 and -2 as answers, whereas remember that symbol is only referring to the positive one. So to make this correct, if I'm saying these two things are equivalent, then I should put plus or minus in front. So just be careful that with even roots, you may need to put plus or minuses in front of your square roots, depending on the context. Okay, so that seems quite straightforward. If we've got a number to a fraction, then that fraction, that denominator, is simply the root, and then you can work that out. So 8 to the 1/3 is the third root of 8. Great, but I did say there's two aspects to a fraction, and we've only had a 1 at the top here. So what happens if there's a different number, like this 5 here? Well, it actually just behaves just like any other power. In fact, you can think about 5/3 as being 5 times 1/3. In which case, this bit gives you the cube root, and this is just the power of 5. So you still have a normal power on the top, and the root is the number on the bottom. So if we take this example here, this is the same as saying the cube root of 8 to the power of 5. We've still got the power of 5 acting just as normal. Now, it doesn't actually matter which way around you do this, so I would say doing 8 to the power of 5 and then cube rooting it without a calculator is a bit tricky. So a better thing to do would be 8 cube rooted and then do that to the power of 5. So it doesn't matter which way around, but it's easier this way. The cube root of 8 is 2, so this is 2 to the power of 5, which is 32. 2, 4, 8, 16. Yes, 32. Just had to check there for a moment. A bit early in the morning for my brain. So, nice and straightforward. What happens when we've got a fraction to, well, any power? You can always split a fraction into the numerator to that power and the denominator to that power. So we can just say this is 16 to the half over 25 to the half. And half just means the square root, so this is going to be 4 over 5, but we have to put the plus and minus because we could have a plus or a minus here and a plus or a minus here, and of course there are 4 situations. You can have a plus and a plus and a minus and a plus and a minus and a minus, but in the cases where you've got both the same sign, then they're going to be plus, the overall fraction is going to be positive, and when they're different, it's going to be negative. So I can just bring that outside as one plus or minus sign. If I look at this one here, it's exactly the same thing. We're just going to split and do the top number and the bottom number. So 4 to the 3 over 2 and 9 to the 3 over 2. And I'm going to do the roots first because it's just easier to deal with smaller numbers. So the square root of 2 is going to be plus or minus 4, plus or minus 2 rather, and then cube that. Well, hang on. If it was plus 2, we'd get positive 8. If it was minus 2, it would give you minus 8. So we still have the plus or minus coming in here. And if you think about it the other way, if we had cubed it, positive number, and then square rooted it, we get the plus or minus. So I think we still want to have the plus or minus on this. And what did we say? We said take it down to 2 by square rooting and then up to 8. And here take it down to 3 by square rooting. We've already got the plus or minus. And then cube it. It's going to be 27. And then this last example is just asking you to rewrite this in a different way. Well, of course, the square root of 3 is going to be 3 to the half. And when you raise something to a power and then to another power, you times them together. So this is just going to be the same as 3 to the 5 over 2, which makes the x value 3 to the power of x is 3 to the power of 5 over 2. It must mean that x equals 5 over 2. It's really sensible to leave your powers as fractions. Don't be tempted to write things like, 3 to the power of 2.5, because then it's very difficult to see the two different powers that are happening here, the power and the root. So it's much better to leave it as a fraction where possible. Now, of course, you can have all the other things that you do with indices. So you can do things where you sort of say a to the m times a to the n is a to the m plus n, where you combine indices, and that's supposed to be an n, not an m. Oh, it's all going wrong. Try again. All of that can still happen with fractions. It doesn't change how you do these things. You'd still just add them together or multiply them together like we did here. It's just, what does this fractional index actually mean? If you're left with a fraction at the end, it means a root with a, of the denominator, the order of the denominator, and it means a normal power of the order of the numerator. Any questions and comments, pop them down below. Otherwise, cheerio.